Okay, so real fast, we're going to talk about removing discontinuities and what that means. So earlier we said that whole discontinuities, or any point where there's just a hole in a line or in a function, they're called removable. But like, why is that, right? So removing discontinuities is the concept of just like, if this function here, where there can't be a point here, this point doesn't exist, if we just like fill this point in, then it exists now, and this line is continuous now, right? I mean, that's just it. So we're gonna look at 2 example problems real quick. Okay, but like what does just filling the hole in mean, right? So we have this problem right here. We have x squared plus 9x plus 14 over x plus 7. So if you take this function here, right, and factor the top, you get x plus 7 and x plus 2 over x plus 7. So you see these 7's cancel out, and there's going to be a hole at x equals negative 7, right? So on the function at negative 7, there's going to be a hole, and the function's going to keep going, whatever. But if we wanted to make this continuous, we would have to fill this hole in and just put a point here. But like, how would we find what point that is, right? So we have the x value right here. It's negative 7. So you know the first point at the coordinate, because every coordinate point is x, y, right? So we have our x, we know it's negative 7. So then how would we find the y? Well, we can't plug it into this function here because obviously the bottom is going to equal 0, and that's not how that works. So we have to find the limit when x is approaching negative 7 of this function. So to do that, we already did the first step. We canceled out the x plus 7, so we're just left with x plus 2. So now we're looking at the limit when x is approaching negative 7 of x plus 2, right? And that'll just give us the y value, because it'll show like where the line is approaching from the left and from the right. So if we just plug that in, we get negative 5. And that's going to be our answer, is negative 7, negative 5. And so the point that we're going to fill in is going to be right here at negative 7, negative 5. So if you want to make this function continuous and you wanted to plug that hole, you would put a point at negative 7, negative 5. So we're going to look at one other problem real quick. Okay, so we have another example up right now, and it says the function f is continuous for all real numbers, and f of x equals x squared minus 4x minus 12 over x minus 6 when x does not equal 6, then f of x equals what? So what is this question asking you? Well, it's saying it's continuous, it's giving you that. So it's saying there's no holes in it, right? So this function is true for every x value except for 6, right? Because at 6 there would be a hole, so this function can't be true at 6. So it's asking you what point you could put at 6 to fill in the hole that would be made by this. So it's the same thing we just did, pretty much, right? So first thing we do is we find where the hole is at. Spoiler alert, it's at 6. So you have x minus 6 and x plus 2 on top. That 6 is crazy. Over x minus 6, and the 6's will cross out. So x equals 6, right? That's what you have. So then you would plug this back in to the limit, which is just going to be x plus 2, because we cancel that out. So which is 6 plus 2, so you're going to get 8. So the point is going to be 6, 8. Yeah, so it's just asking what f of 6 is if it were to like work in this, pretty much what this means. That's it for this though, so we moving on.